Good day. In this presentation, I will present a solution for designing an efficient irrigation system for a vegetable farm. The objectives of this task are to compute the water requirement or discharge, design an irrigation canal, determine the required pump horsepower, and explain the application of a ramp pump in farming. Take this for a scenario. I am assigned as a farm technician for a 1 hectare vegetable farm. The crops require 60 mm of water per day. The available water source is a small river located 20 meters away from the farm. Additionally, the field is slightly elevated by 3 meters above the water source. The farmer's goal is to develop an efficient and low-cost irrigation system. Let's first compute the water requirement. Given that our area is 1 hectare or 10,000 square meters, and the water requirement is 60 millimeters per day, which is 0.06 meters per day. To get the discharge, let's head first on computing the volume. The formula is volume is equals to area times depth. Therefore, substituting the given volume is equals to 10,000 square meters times zero point zero 0.06 is 600 cubic meters per day. Let's now convert time. 1 day is equals to 86,400 seconds. Now to compute discharge, we have discharge is equals to volume divided by time. The volume would be the 600 cubic meter. Therefore, discharge is equals to 600 cubic meter divided by 86,400 seconds is 0.00694 cubic meters per second. Converting it to liters per second, therefore it is 6.94 liters per second. That is the discharge. Let's now design the irrigation canal. So let's just say a trapezoidal canal is selected due to its stability and cost efficiency. The assumed velocity is 0.5 meters per second. We need to compute the area by this formula, which is area is equals to discharge divided by volume, or by substituting the given, area equals to 0.00694 divided by zero point 0.5 is equals to 0.01388 square meters. Let's assume the bottom width is 0.20 meters, the depth is 0.15 meters, and the side slope is 1. Adding the width and the depth multiplied by depth, or 0.20 times plus 0.15 times 0.15 is equals to 0.0525 square meters. Since computed area is greater than the required, the canal is adequately sized. Why trapezoidal canal? Well, it minimizes erosion, easy to construct, and it provides stable water flow. Next is computing the horsepower requirement. Given that the discharge is 0.00694 cubic meters per second, the height is 3 meters, and the efficiency is 0.7, the formula would be horsepower is equals to discharge times height divided by 75 times efficiency. Therefore, horsepower is 0.694 times 3 divided by 75 times zero point 0.7. The horsepower would be 0.00397 HP. In practice, this is very small, so a minimum of 0.5 horsepower pump is recommended. A ramp pump is a device that uses the energy of flowing water to lift water through higher elevations without electricity. The working principle is that the water flows through a pipe, pressure builds and closes a valve suddenly, and then this creates a pressure surge. Then water is pushed upward to the field. The advantages, on the other hand, are no fuel or electricity required, low maintenance, and it is environmentally sustainable. But the limitations is that it requires continuous water flow, needs elevation difference and lower efficiency. Given the presence of a river and a 3-meter elevation difference, a ramp pump is a feasible low-cost alternative provided sufficient flow conditions are available. In summary, the required discharge is 6.94 liters per second. A trapezoidal canal was designed for efficiency and stability. A zero point 0.5 horsepower pump is recommended, and the ramp pump is a practical alternative for sustainable irrigation. This design meets the requirement for an efficient and economical irrigation system.